All right, this is Mr. Voigt, and this is for my electricity and plumbing class. Um, in class, we have talked about the characteristics of electricity. We've talked about, the atomic structure of electricity, how electricity works at the atomic level, and then we started getting into the characteristics of electricity. And what that refers to are the things on this wheel here. So the three main characteristics of electricity are voltage. And voltage can be represented with a V, obviously, but it also gets represented with an E. Um, the E is for energy potential. You don't need to know why. Just know that V and E both represent volts. So if you see a like in here, it's a V in these formulas, but it could just as easily be an E there, and it means the same thing. So all of these have at least two ways of looking at that. Amps would be the next one. So amperage is the second characteristic, voltage and amperage. Amps are also represented with, so it's either a capital A or a capital I, and the I stands for intensity. And again, I don't want to get too much into the energy or intensity. Just understand I and A are the same thing in these formulas. So volts, amps, and resistance. Those are the three main. Resistance is represented with an R, just like the other two, or omega. So this is A or I, V or E, R or omega. Okay, we call them ohms. So the unit of measurement here is ohms, the unit of measurement here is a volt, and the unit of measurement here is an amp. So we call it resistance, the unit of measurement is ohms, represented with an omega symbol or an R. The fourth one, so those are the three main ones. And let me come back to the fourth one. So those three main ones get used in something called Ohm's law. And Ohm's law is this. It says that there's a mathematical relationship between these three parts of an electrical flow. Um, Voltage, as you know, this is the pressure. It's like water pressure behind water. Like the water tower puts a lot of water on top of, if you ever dove to the bottom of a swimming pool, there's pressure above you. That's why it kind of puts pressure in your ears. Okay. And that water will then push out through a pipe faster than as it gets lower. It'll still go out the pipe, it just doesn't go out as fast because there's not as much weight above it pressurizing it. Well, voltage is the pressure on electricity. And we talked in class a little bit how they get that voltage, but for right now, just understand that there are ways of producing pressure. What that pressure does is it allows electrons will not flow. They in copper, the electron in the valence layer, will leave one atom and go into another and pop the electron in the valence layer from the next one to the next one and so forth. But they do it randomly. They don't go in a line. So when you apply pressure to it, you then get that electron flow. So without pressure, those electrons are still moving. They just aren't moving in a flow type motion. So you need this to happen. So that's the pressure. Amps is the volume. So the amount of amps of electrons, I'm sorry, the amount of electrons passing a point in a given time. Usually this is per second. So to get 1 amp of current, a certain number of electrons have to pass a point in any given second. And it's a really big number. I can't remember what it is right now. It's billions of billions. Okay? That's how they say there's so many zeros. It's billions of billions. So that's quite a bit. There's probably a name for that, but I don't know what it is. Anyway, so that's the number of electrons they have to go by any point in a second to equal 1 amp of flow. It's a lot because these are on the atomic level. So anyway, we have we have lots of things in this that we use in our households, even in our residences, that pull 15, 30 amps, which means you have billions upon billions upon billions upon billions of electrons going past a point in any given second flowing through those wires. Okay, so this is pressure, this is volume, and this is impedance. So what it means to impede something, if I impede your progress, I get in your way. So the resistance is things in the structure of things or well, anyway, anything that's in the path of the electricity that slows it down. It impedes its progress. So obviously, just the material that you're pushing it through, the wires, have a certain amount of resistance. They do not conduct electricity perfectly. Certain materials conduct it much better than others. We've been over that, you know, the difference between conductors, insulators, and semiconductors. And that difference boils down to how many electrons they have in their valence layer. We've been through that. I don't want to do that here. There's another video I have that talks more about the atomic stuff. But anyway, so the amount of impedance you put in between, you know, in the electrical circuit to impede its flow, that is resistance. So how much electricity is being used depends on these three things generally. The fourth thing, well, let me go ahead and come over to Ohm's law. So if you're going to do volts, and you want to find volts on this little thing, you cover it up. And you have amps times resistance will get you volts. Amps times resistance gets you volts. And if you come over here, volts, amps times resistance, right? If you want to find amps, we cover up amps. Volts divided by resistance gets me amps. So if I come over here, this is my amps. Volts divided by resistance equals amps, okay? And the same with, if I cover up my R, whoop, I have to do it with this finger. Volts divided by amps gets me resistance. So here's my resistance. Volts divided by amps gets me resistance. Okay? So this is the simple version. When I add a fourth one, and there's only three combinations when you only have three things, right? But when I add my fourth one, which is watts or power, power is measured in watts. So this would either be P or W for watts. And this is work. What is done by this flow of electricity? It produces heat often, it'll produce light sometimes, it'll power a motor, or whatever it is doing in work can be measured in wattage. That's why you have a 100-watt light bulb, talks about how much electricity that bulb will use. Okay, now that 100-watt bulb produces a certain amount of light. It also produces a certain amount of heat. So there's two types of work being done by that light bulb. Anyway, so when you add that fourth one in, it comes down here, right? And now you have, in each quadrant, you have three different formulas. All you need for either one of these, if I have two of these variables, I can figure out the third. Any two, I can figure out the third. Over here, any two, and I can figure out the other two. That's all you need. Two of the variables in any electrical circuit, and you can figure out the other two characteristics. So over here, though, that puts the number of formulas you need for each characteristic at 3. And so if I have two variables, I will find, and I'm trying to find a third, I'll use the two variables. So if I have my resistance in amps and I want to find watts, okay, where am I at? Resistance in amps. So I will use that formula and I will find my watts. So when I come to find my volts, I'm always going to take, because I have all three variables then, right? If I had these originally and I find my watts using this formula, then I have all three of these named. And when I come over here, I can choose whichever formula I want to use here. And I always choose whatever one I think is easiest. If you like to divide, you do that. If you like to multiply, you do that. If you want to use the square root, you could do that, but it's probably not the easiest formula. You would use one of these two. I personally would use that one because I think it's easier. So that's how I go about doing this. So that is Ohm's law in the formula wheel. Okay? So I'm going to end this video, and then when I come back, I'm going to talk about different types of circuits and the rules that go with them.